Thank you everyone for joining us today on Linkerd 2.11. I think most of you heard about Linkerd, the only CNCF graduated service mesh, and the fastest, the ultra lightweight, the simplest and easy to use service mesh if you are using this in your cloud native stack. And today we're exploring 2.11 because it has ton of new features. And one of the few new features I like about most, that's policies, gRPC retries, and few others. And we will today focus on entirely on the Linkerd 2.11 release. If you haven't heard about service meshes or Linkerd before, we have a two session with Jason Morgan and on the Cloud Native Islamabad YouTube channel. The link is available on the chat if you are watching this session from the YouTube. But today our focus are for those who are already familiar with the Linkerd. And Jason, once again, this is third session with him on the Cloud Native Islamabad. Always pleasure talking to him, and it's always when I always talking to him puts a smile on my face and my energy is blowing up. But thank you, Jason, for being on the Cloud Native Islamabad. Over to you. Start the proceeding, and thank you very much for spending time with me today.
Yeah, thank you, and you're genuinely too kind. So I've decided I've had a long-running Kubernetes cluster out there on the internet. So I'll put some links here in the chat as we go. But we're gonna, instead of doing upgrade on a demo cluster, we're actually gonna do an upgrade on my live cluster and see how that works. So with that all being said, let's talk about Linkerd 2.11 and what's coming with it. Before I go too far, let me just introduce myself. I'm Jason Morgan. I'm a technical evangelist for Buoyant, right? That means it's my job to go out there and talk about Linkerd and why I hope you will give it a shot. So let me start, because I know we've talked about it before, but I like to always do a quick warm up. What is Linkerd? Linkerd is a very lightweight, very fast, security-focused service mesh that is built for Kubernetes. We've been in production a long time. We've got a Slack channel that has a ton of folks in it. We'd love to have you. We also have a Discord, which Simon can tell you about as well. We've got GitHub stars, but if you like it, go ahead and give it a little star button. That's a nice vanity metric. We are a CNCF graduated product. So this summer, we hit the CNCF graduate status, which means CNCF decided we are at the highest level of maturity for a project in the CNCF. So it was a nice endorsement. Lots of folks use us. So yeah, that's a little bit about Linkerd. What does Linkerd do, or what does a service mesh do, really? A service mesh provides you observability, right? That is some additional metrics around what your applications are doing. It provides you additional reliability, right? So the ability to make your connections work more of the time in a more predictable way. And it gives you security. And it does it without you changing your application code. So it does it by injecting a little, call it a sidecar or a little proxy in between your applications, and the proxy will manage traffic and do some stuff for you. So why is Linkerd good? Well, that's a relative statement, and you need to tell me if you like it, but we think the following things make Linkerd, the best service mesh, right? It works. When you install Linkerd in your cluster and you have an application running, your application still works before and after the fact. And you don't need any particular configuration. It's extremely lightweight, right? We've got some performance benchmarks, which we think are very favorable for Linkerd, but we'd love to see you try it in your own environment, see if you like it. It's really easy to use. You're going to see me today do an upgrade on, my personal cluster that I use for showing off Linkerd, and it will hopefully work and be really simple. And all the security settings are on by default. Now, with that being said, right, Linkerd 2.11, and I'm going to talk about it earlier, and William coined the phrase, or maybe not coined it, but was dropping this phrase, and I decided to copy it. Linkerd 2.11 is the first time we've shipped Linkerd with some really effective foot guns. So that is great tooling to shoot yourself in the foot if you're not careful. I'm going to tell you about what they are and how to avoid them. And then I'm going to let you know that with everything in Linkerd, when we add things like policy or any additional complexity, we make it so that you have to opt in to the complexity. So by default, everything continues to work the way that worked before. But with policy, if you choose to opt in, there's some big things to be aware of. And what that is server-side policy. I'm going to talk about this a ton more later, right? But what we're doing is we allow a server in your Kubernetes environment, so that is any service that is meshed, to decide what communication you will allow to what port on a given deployment or on a given pod, right? And that's server-side policy. That is inbound to that service. In support of that, we've added 2 new custom resource definitions to Linkerd. So I've made a lot of hay in the past about how, Linkerd installs and you get 2 service meshes, or two custom resource definitions. Where if you look at some other service meshes on the market, I'm not gonna name names. There's a lot of new custom resource definitions that come in, and each custom resource definition represents additional complexity in the environment. So now we've gone from 2 to 4. Right, and those are all in support of policy. Quick agenda. We're going to talk about how do you upgrade to 2.11, and specifically I'm going to talk about the things to worry about when you upgrade to 2.11. I'm going to do the briefest of talks about what got added as far as gRPC retries, and then I'm going to spend a lot of time talking about policy. Folks that are watching, good so far? Can you make a comment in the chat if there's anything that you want me to go back to, or if you're cool to carry on? Also, just say hi in the chat. I'd love to hear from you. All right, well, I'm going to keep going anyway, but hopefully I'll hear from somebody. So first and foremost, upgrading Linkerd. So there are docs on this, and I'll actually pause and just hop into our docs really quick. Right. If you want to know about upgrading Linkerd, just go over to our docs and check out the upgrade. This talks about using the CLI to do an upgrade, right? Which is what I'm going to do today. There are also steps for using the Helm section, right? So if you're using Helm, it's a little bit easier to handle the upgrades. But we're going to do it with the Linkerd CLI, and I'll show you all of that as we get to it. But anyway, if you're looking to upgrade and you have questions, go to the docs. What you need to know. You should do upgrades in sequence. If you're at 2.8, you should go to the latest 2.9, then go to the latest 2.10 before you go to 2.11, right? If you're going to do a big shift from something like Linkerd 2.8 to 2.11 or anything further back, right? Either uninstall Linkerd and reinstall it at 2.11, or do that sequential upgrades, right? Depending on what you need to do. I hope that makes sense. There are some breaking changes in 2.11, right? So 2.11, the way we do semantic versioning, 2 is the version of Linkerd. The thing in the next column, right? This is our major version. So going from 2.10 to 2.11 is a major version change from Linkerd's perspective. So they're breaking changes. And then the last one here is our minor, where we put minor changes as well as any patch releases. So in 2.11, there's some change to the way ingress mode works, and I'd ask you to consult your docs around ingress mode and also just test it out in your environment. Long story short, when you're using an ingress with Linkerd, in a lot of cases, you don't actually have to set the Linkerd proxy into ingress mode. You can just set it in standard normal proxy mode, and the behavior, will be what you expect. And that's particularly pronounced with the ambassador or emissary ingress, because that works with no configuration at all. If you're binding to or if you're sending traffic to yourself inside your application, you need to check what address you're binding to because some forwarding to yourself will no longer work because we changed the way that the proxy inits. Long story short, what we're going to do is drop, like when you're talking to yourself, when an application is talking to itself, we want to keep Linkerd out of the equation because it doesn't add any value there. So we can speed things up when you talk to yourself internally. Just need to make sure that you're configured correctly. The multi-cluster installations have to drop their link and relink, right? And you can read more about it in this particular PR. All in all, it's a fairly easy upgrade, which you're going to see. Well, fingers crossed. We're going to see in a bit. Any questions before I go on? All right, I'll say no. In 2.11, we can now, oh, thank you, Basharat. In 2.11, we can now do gRPC retries. So if you've been using Linkerd for a bit, you have a concept called a service profile. And inside a service profile, you essentially document the API of your application, and you tell the Linkerd mesh about it. And if you want, you can start doing retries on particular calls, right? But that really only applied to messages without bodies, right? We changed that in Linkerd 2.10, so you could do bodies up to a certain size. And in 2.11, you can now do retries for gRPC requests. So if a specific gRPC request is safe to retry, you can now set it in the service profile, and Linkerd will honor that. So that's exciting if you're doing gRPC with Linkerd, which is kind of, a little bit of a deeper topic. Beyond that, we have policy. So the thing to know about Linkerd policy is it's really good to be able to enforce policy at layer 7, right? Doing application aware policy is foundational to setting up like a zero trust environment, where instead of setting up tokens or building your own authentication system, you instead just say, hey, listen, if service A can connect to service B, it is authorized to do it. And that's the end of that story, right? So that's a good setup, right? But it comes with some risks, right? And we're going to talk about all the great ways that you can cause yourself to fail with policy in 2.11, right? That being said, if you need it, use it. It's fantastic, right? But there's complexity there that you'll have to opt into, and you want to test things and make sure you know what you're doing. So let's talk about this. We give you a new mechanism to decide for any given deployment or stateful set or daemon set. You can say what things are allowed to talk to it on what port, right? This is built on top of Linkerd's MTLS. And it adds 2 new custom resource definitions, the server and server authorization. Right? And we'll talk about those in more depth. So we're now at 4 CRDs for Linkerd. How is policy expressed, right? You set policy in 2 ways, right? You have an annotation that will go on your workload or on your namespace that will set the default policy for that workload, namespace, or even cluster, right? And then you will create exceptions to policy based on your own criteria, right? So step that back, right? All policy in Linkerd 2.11 is server side. So your client isn't gonna be, we're not gonna say who can your client connect to. We're gonna instead say who is allowed to talk to this particular deployment, right? The other thing is that it's all denied by default, right? Unless you say something is allowed to happen, it can't happen, right? And we'll talk about that more. But in Linkerd, you allow things, you don't deny things, right? In Linkerd policy, you can only allow things, you can't deny things, because everything gets denied once you start allowing things. Every cluster has a cluster-wide default inbound policy set at install time with this particular setting, right? The default install for every Linkerd is to say that all traffic is allowed everywhere, right? And if you change that, you need to have specific allowances created, otherwise everything will stop working. You can override it at install time, and that's a fairly simple one to do. The other one is your proxy's default policy is fixed at startup time. So when that pod starts, it grabs its policy, and it doesn't dynamically reload that, right? So you need to restart the pod to change the way policy works, right? For this default, right? Servers and server authorizations are dynamic. I hope that made sense. And if you dig into the proxy, you can see it, and you can also see all your policy stuff in Buoyant Cloud. So let's talk about the available default policies, right? You have, let me go back. You have all unauthenticated, which is how we all start, right? So that means things are just going to continue to work the way you expected them to work. Beyond that, we can do cluster unauthenticated, where you allow requests in the cluster to work if they're unauthenticated. These two are fairly safe, or these two are safe. The thing about the cluster unauthenticated, we'll talk in a minute. You have to set what the subnets are for your cluster at install time. All authenticated, right? If you enable all authenticated by default in your environment, you will start seeing things break if you haven't created servers and server authorizations to allow things like the Kubelet to do health checks and readiness checks. Cluster authenticated, again, very similar to all authenticated, but requires it to be inside that cluster's network. And then denial, right? Which is a good starting point if you want to do zero trust. Set up denial and explicitly allow every bit of communication that you want to have happen, right? But it requires work, planning, and testing before you do it. A note about cluster networks. Yeah, so this is the other one. We can't easily see what the cluster's in network IP range is, right? So we have a default setting, and when you go into actual production installs, right, you need to go beyond just Linkerd install and do Linkerd install with settings to include what is the cluster network on this cluster. And you can do that on install or upgrade. How does it feel to be denied? So this is once you start using policy, you can expect things to start getting denied, right? So let's talk about what that looks like for your application. If we know it's a gRPC connection, you'll get a gRPC status error that is appropriate to that issue. If we know it's an HTTP connection, we'll send you a 403, and otherwise we give you kind of a generic TCP connection is refused. Yeah. And as you update policies, Linkerd will start killing established sessions. So I guess the message, and I hope everyone who's listening has taken away the message that policy is something that you have to be really prepared for, because it's really easy to harm yourself with policy in your environment. So don't go turning on policy in your production cluster without testing it, because you will start seeing incidents. Good so far? Any questions? I'm going to use this time to take a drink. Simon, how am I doing?
Wonderful. I have few of them, but I will ask later at the end. So you will continue on. So far, so simple and so easy to grasp.
Okay. Well, it'll be a little bit easier when we do some of it, right? And then I'll try and make a video specifically on policy. Maybe we can team up later to do a policy walkthrough, you and me, and we'll talk about how it works. So let's talk about the new CRDs. We have a Server CRD, right? This is pretty cool. It allows you to basically define for your application, right? What is the port and the protocol that's going to be used, right, for any given setup, right? So you select over a port and a set of pods and a namespace. You give it the protocol. If you give it a protocol hint, which you should do, you'll be able to avoid Linkerd doing its own protocol detection, which will marginally speed up your application traffic. So it's a good deal. You have to define ports inside your application that we're going to select on. Okay, that's a really important point, and it's so important that we're going to talk about it later. Servers can match multiple workloads, right? So as an example, and we're going to actually do this later, where we just go ahead and break our Emojivoto application. The admin port, so in this example, what we're doing is we're selecting the admin port on every single pod in this environment, right? And then we're going to apply a policy that lets unauthenticated traffic through to the admin port, right? And the admin port is where we'll do things like our health check, so that like our pod can actually come online. Servers deny all traffic. So as soon as you set up a server, you have to set up a server authorization at the same time, or it will start denying traffic, right? So again, this is something that you have to pre-plan and do your initial runs in an environment that it's okay to break stuff, right? Don't test this. This one is not I hear a lot of people say test in prod. Don't test policy in prod ever, right? Like make sure you've got it right, then go to prod. But essentially you have to create a server authorization that references a server. This is going to sound weird, and it becomes a lot easier when we actually do it, right? But a server authorization, just kind of like a service object, you'll select pods based on labels. Well, a server authorization will select servers based on labels, right? So you select one or more servers and you describe the type of traffic that's allowed, right? So this is allowing our pods to start essentially once we set up deny or all authorized, right? What we say is when we see anything, with a server name of admin, right? We're gonna set the we're gonna allow unauthenticated connections to that server, right? And if we look back at the server, right, the server basically looks for all pods and selects the Linkerd admin port. It selects all pods that have a port called Linkerd admin, right? And this says, okay, well, if you are the admin server, we're going to allow unauthenticated traffic. So that is all ports that are Linkerd admin to take unauthenticated traffic, right? Which you need for a standard application to start up. ServerAuthz can match multiple services or multiple servers, right? So this is essentially the backend for Emojivoto. So Emojivoto is an app where we have a web front end and two gRPC backends, right? They each have a gRPC port. And what we're saying here with this policy is that if we see a server where it matches the label Emojivoto internal gRPC, right, it will allow meshed traffic from the web service or from applications that have the web service account associated with them. Yeah, so I talked about this a lot. The kubelet probes need to be authorized. That first policy that I spent so much time talking about, right, that's important because if it doesn't work, your pod's not going to start up. And I'm going to intentionally break our environment when we go do the demo. So you'll see this. You'll see this there. This one, right, like the default policies are not read dynamically, right? So again, I talked about this a bit, but if you change the policy in a namespace, it's not going to, or on a workload, or even at the cluster level, right? Like it's not going to take effect unless you roll the pod. But changes to the server and server authorization are read dynamically, right? But that default policy for your namespace or whatever only takes effect when we roll the pod. Yeah, and you have to reference ports in the pod spec, right? So the long story short here is looking at it, right? What people really care about is communication to an application on a port by port basis, right? Because like I don't care about the admin port, but I sure as heck care about my application port where I'm serving application data, right? So it's a thing that you'll want to distinguish, and so ports are really important, and you have to have ports inside your pod spec. So what do you think? Y'all want to do an upgrade? Shall we do it live? I'm gonna take that as a yes.
I am absolutely waiting for it.
All right. So let me do some stuff here. I've got a terminal running. What we're going to do is watch kubectl get pods across all our namespaces. Let's talk about what I have. I have a cluster. It is connected to Buoyant Cloud. Let me make this a little bit bigger. I have a cluster. It's connected to Buoyant Cloud, which is, which is Buoyant's attempt to build a managed service around Linkerd. I think it's really cool, but we can talk about that. You can talk to me about that if you want on your own time. So we've got an environment. I've got a cluster. Let's just do a quick check, right? If I do a Linkerd check, I see that my cluster is healthy, but wait, what's this? I've got some issues, right? My control plane is not up to date. I'm at 210. I should be at 210.2. I should be at 211.1. Right? Same thing for the proxy. Same thing for Viz. So let's do an upgrade. All right. So let's check my Linkerd version, make sure that it's current. All right. So I'm running the latest 211.1. If you are watching, which you are, obviously, if you're here right now, you can check out my Linkerd dashboard. You can check out the emoji photo application, and you can poke around this cluster as we're doing this. So let's get a little bit risky. I'm good. We're recording this. Excellent. So if I fail, it will be out there for perpetuity. So what I'm going to do is I'm going to use the Linkerd CLI to do an upgrade. All right. And so what I'm going to type out here is, can you see this text okay?
Absolutely.
Okay, great. I'm typing the Linkerd upgrade command, which is going to spit out the YAML to upgrade this cluster. Now, the reason it's easier with Helm, right, is because Helm will automatically do all the pruning that you need to do. In our case, we're using Kubernetes objects, so we're going to have to do it ourselves. So we're going to do a kubectl apply, but we're also going to do some pruning to remove objects that are no longer required as we go forward. And this is all directly in the upgrade docs. So let's upgrade our control plane. Here, let me change this from -A to -N, Linkerd. Right, let's watch the upgrade going. We see I have new things coming up and old things going away. And again, I haven't tested it on this cluster, so fingers crossed, folks. All right, as we fill the time, anyone want to hear a UDP joke and a little networking joke? So I have a UDP joke for you. You may not get it.
Absolutely. please share.
No, that's the joke. Is you may not get it.
Yes, absolutely. But
so that one used to kill with network engineers. Okay, so we did the first prune command, which is good. So we're getting going, but we need to run the next command. So let me do that. Paste away. Let's go. Same thing, running the Linkerd command again, doing more pruning. Oh, hold on. What's my kubectl version? Oh, darn, my upgrade failed. What a bummer. I understand you're deprecated. Oh, darn it. Okay, my upgrade failed. So I'm gonna have to do it on a K3D cluster. Sorry, folks. CTX. Luckily, I prepared for this eventuality, but it is quite the bummer. Actually, let me just delete this. K3D cluster delete Linkerd. Yep. I'm gonna create a new Linkerd cluster. Oh, that's sad. I thought I was going to be able to do it live, but I can't. So you're just gonna have to watch the local version. I have something about my Kubernetes version. Something about my Kubernetes version stopped me. Oh no, darn it! It's I forgot my cluster's being managed by Flux. So folks, if y'all want to see Flux in action, right? I just tried to upgrade my cluster with a local command, and it's being managed by a Flux environment that went back through and reset it. That's actually awesome. So let me get this fired up. Oh, darn it. I wonder if I can break Flux on the cloud. Well, no, we're not going to do any of that stuff here. Sorry about this. Let me just, we're just going to run some quick commands to install Linkerd 2.10, and then we're going to go back and upgrade it. Unset Linkerd version. There we go. So if I do Linkerd version, I'm at 2.10. So we'll do a Linkerd install. Linkerd install. Go apply -f -. That's really funny. All right. Well, that's how you can install and roll back Linkerd live. KNS defaults. All right, so we've got an environment. We're going to go ahead and install Emoji Voto. So first let me install Linkerd dashboard. So let's do Linkerd check. So we'll wait for Linkerd to come up. So I'm going to install 2.10. Then we're going to roll back to 11. And while we're waiting, actually, I'm going to see if we can't get that upgrade going anyway. So give me a minute. All right, so we got Linkerd installed. We're going to run Linkerd viz install. All right, so we're going to run the viz install and let it go, and then we're going to upgrade Linkerd, and we're going to upgrade the cluster. And after that, I'm going to send through some updated YAML to get Flux to upgrade my the cluster that y'all have the dashboard URL for. So watching pod. So this is just an in-memory cluster. So instead of doing the full thing, we're just doing a local K3S cluster running on my desktop. And let's go from there. Okay, so that passed. I'm just going to install the Emoji Voto app and get it injected. And then we're going to upgrade with a live application. So I'm at Linkerd 2.10.2 right now, but let's go ahead and update our CLI. So we're going to start just grabbing the latest version of the CLI. Right, so now when I type Linkerd version, we'll see that I've got the 2.11 client, but I'm on 2.10 on the cluster. Let's go back to my upgrade command. Right, and so we're gonna run that same command that we were talking about before, and we're gonna see Linkerd come back up. Here, I'm gonna type. Thanks. Okay, so that's going now, and so we'll run a Linkerd check. Right, wait for it to come up. Right, so it says it's come up, or the new Linkerd stuff has come up, but Viz is still out of date. So that Linkerd upgrade command, you only actually use it for the control plane. To upgrade Viz, we just do Linkerd Viz install type K apply -F. Right, so the upgrade command basically reads some data that's important from the control plane, but the Viz component, we don't actually need to save anything. So we can just run the upgrade command directly and do another Linkerd check. And it'll tell us when Viz is healthy again. Oh, and I need to run one more prune command. All right, Prometheus is taking a minute. I want to paste away. Again, these commands are all in our docs, so they'll explain what's going on. Now Linkerd is gone. So if you were watching, the control plane went from, I think, 4 or 5 components down to 3, right? So we have destination, proxy injector, and identity. So that's the new Linkerd environment. Now it looks good, right? But what we have here is we still have the emoji photo applications that are using an old version of the proxy. So if we run Linkerd check again, it will tell us that. Well, it should tell us that. Okay. Well, anyway, we've got an old version of the proxy. So I guess it's not checking the proxy. So -- was it proxy? Yeah, proxy -n emoji photo. There we go. Yeah, perfect. Sorry, that was a bit of user error there. If you see up here, when we check the proxy in the emoji photo namespace, we see that it's not currently up to date. And so we're going to fix that right now with a kubectl rollout restart. Come on, buddy. Deploy -n emoji photo. So we're going to roll our emoji photo pods into our brave new world of Linkerd 2.11, and they're all going to come up fine, and emoji photo is still working the way we expected. So that there is the entirety of a Linkerd upgrade. And I think I have time. Sam, do you mind if I do a little live debugging and get that other cluster properly upgraded?
Yes, absolutely.
All right, cool. Okay, CTX, CNS. So what I'm going to do here is I'm going to run that Linkerd upgrade command again. But this time, what I'm going to do is I'm going to output. Instead of applying the YAML to the cluster, I'm going to output it to the repo that is managing this environment. Right? I'm on main, so let's do. We're going to test and prod here. We're going to do Linkerd upgrade into, I believe it's GitOps, Flux. Hold on. Runtime. Manifests, Linkerd, Linkerd, come on, buddy. Oh yeah, wrong one. Runtime source Linkerd / Linkerd.yaml. So I'm going to pass the upgrade right to the Linkerd.yaml, right? And we're going to do the same thing for the viz. All right, and then we're going to be really bold, and we're just going to git add dot git commit -m YOLO, because we do only live once. Git push. And let me get my Git API key. Excuse me, I'm going to do this on another tab. See, I'll see my password. Git client API key. Copy note. Here we go. We pushed. So now, if we look, let's do watch kubectl get customization. -a, sorry. -a. We're going to see Linkerd upgrade over here. So what does it say? So it's healthy right now. So it's applied a revision successfully. But we're going to see that get reverted here in a second. And we can force Linkerd to, or we can force Flux to like look through and do a reconcile, and then we'll go from there. So I really want to get policy in because I want to show you breaking the application a little bit. It's going, yeah, okay. We've got reconciliation going for Linkerd. So now if you look up here, Linkerd is reconciling, right? So we're going to start seeing some stuff. So let me break out of this and just look at the pods in the Linkerd namespace. We've got some stuff terminating, coming online. And we should be able to go to the Linkerd dashboard that I sent you originally. And eventually it will work. So right now my dashboard is down, which is not great, but let's see if it comes back up. Okay, so that's Linkerd, but let's see how Linkerd Viz is doing. Linkerd Viz, you should still be routing over there. I don't see quite why you're down. Okay, so Linkerd check. Okay, so we've got the control plane is up to date and healthy. That's good. Viz is still upgrading or waiting to upgrade. We're going to check Flux to see how it's gotten with Linkerd Viz. So it's not doing the reconciliation because it's still finishing with Linkerd. That's annoying. But yeah, well, we'll let that go. I don't want to run over time here. But what we're doing is we're going to let the Flux thing finish going, and we'll do that on its time. Let me just go back to my local cluster, and we'll break emoji voto there. KCTX. There we go. So in this environment, right, going back, let's get out of this, and we'll watch all pods. In this environment, I've got emoji voto running, right? So what I'm going to do is I'm going to add an annotation to the emoji voto namespace that's going to deny all traffic, right? And it's not going to be as exciting from the UI, but at least we'll get it done in a timely fashion. So let's do this. I'm gonna annotate. So K annotate namespaces, emoji voto, and the annotation is going to be config.linkerd.io/default inbound policy. I sure hope I typed that right. equals deny. So what I'm changing here is the default inbound policy for the Emojivoto namespace, right? Quick guess. Anyone want to know what's going to happen, or anyone want to guess what's going to happen with Linkerd or with the service now that I've got it? So if I do, you know, k port dash forward service slash web dash service 8080, oops, 80:80. All right, let's do 85 dash n emoji. You want to guess what we're gonna get if we browse over there? It's gonna work, not work? What are we thinking? Okay, well, it works. Still works. Everything behaves as normal, in spite of the fact that we've now set a policy for default deny, right? And the reason it fails, the reason it fails is because, or it doesn't fail, fails to fail, right? The reason it still works is because you know, that policy takes effect on application startup time. So if we want the policy to come in and start breaking stuff, we actually have to do a rollout restart. Right, so we're gonna restart the deployment in the Emojivoto namespace, and you're gonna see something interesting happening. Right, I have a new version of Emojivoto coming up. Now I set up my manifest correctly that it's not gonna start shifting traffic to these new pods until they're healthy. Right, but with a default deny, right, like if you remember, I was talking about a lot with a default deny, the health check for these applications is never gonna pass. Right, like it will fail forever because the kubelet is being banned from talking to this pod in any way, shape, or form. Right, so we've secured it so much that it doesn't work. And if we want to make it work, we have to apply policy. So if you check this out, there's a policy document. This is all covered in our docs. But if we check out this quick policy document, right, we can see that this has the servers and it has the policies that we were talking about earlier that will allow this application to talk to each other. The really important one for our use case is not Prometheus, is this admin port, right? So I need the server that lets the kubelet talk to the admin port, and I need the server authorization that lets everybody who's unauthenticated connect to it. So once I apply this, I'll actually be able to have these applications come up. So let's do this. Give it to k apply -f. And now we have new servers and new policy come up that will allow traffic to come in to our application, and you know, we can test it. So now we have Linkerd running again, or Emojivoto running again in a healthy way with the appropriate policy in place. Is that helpful? Make sense? The place to go, right, to learn more about this is our docs. So if you go here, right, this is where you'll see the start of what I did today with that server policy, and this is a little bit of a deeper dive into how it works. And both will contain links to the example of the Emojivoto policy that I used, which is what will get us some appropriate traffic. And yeah, that's kind of the whole story. You know, one, thank you for attending. I hope this was useful. If you're interested, next Wednesday there will be an MTLS deep dive workshop where we talk all about how MTLS works. And then if you want to hear about Buoyant Cloud, which is our managed service offering on top of Linkerd, let me know. I would love to hear from you. You can find me on Twitter. You can email me, just jason@Buoyant or buoyant.io. And yeah, that's all I got. Time your.
But who is going to be the author or speaker of this session, MTLS?
Oh, one of my colleagues, Matej David.
Oh, wonderful. Awesome,
Yeah,
awesome.
He's really, really nice, really sharp. Great guy to listen to. So he's done some talks before. But yeah, he'll be doing the MTLS deep dive.
Yes, absolutely. And anybody who listening to us or watching this session, the chat is available, and grab the link and join the 17th November on the session. I think that's MTLS feature is really a wonderful feature. I don't hope you like it as well. But today what we showed up is wonderful. One thing is the upgrade process was so simple and so easy. That's number one. It's not taking a ton of effort going on to understand it. Plus, there are the policy feature that we showed today is really the kind of interesting, because you know the microservices we kind of have. We have a ton of microservices going on. Whether the front end allowed to talk to the database or database allowed to talk to the back end, and the only front end is allowed to talk to the front end allowed to talk to the back end, and then back end allowed to talk to the database. There are the policies in there. But the question is really interesting, I think, Mike, for you. I have asked because I think whenever we heard about the policies, the natural question came into the people's mind: how the network policies are different from the Linkerd policies.
Yeah, it's a great question, right? So network policies work like a bit more like a traditional firewall, right? It is this IP space or this Kubernetes namespace to that namespace, and that's great, right? But it's network level segregation of traffic. What your service mesh policy does is it gives you application aware policy. This application, like my web front end, may talk to my gRPC backend on these ports and these ports alone. It may not talk to some other application's database, right? As an example, right? And everything is explicitly allowed. So you start out by essentially shutting down traffic in the environment and then explicitly allowing what application should talk to what application. And it's enforced in a way that is, aware of the service account that your application came from, something intrinsic to that pod, right? That you don't have to bootstrap a secret. You don't have to hand off a token, nothing like that, right? It is intrinsic to the Kubernetes identity of the pod.
Yes, absolutely. Thank you very much for elaborating the people who are listening to us, because that's really confusing for everyone who watching this. And also, we also see the container startup time. We know that's really important for the workload. But you tell us this, shed some light on that's the newest feature in the Linkerd .211, the container startup time. Tell us why that is so important, and why the Linkerd community thinks it's a missing piece, and we want to add this piece into the Linkerd 2.11.
Sorry, just one sec.
Jason, can you hear us?
Yeah. Shoot, one sec. Sorry, I've got two things going on now. Hold on. Okay. Yeah. So it's basically just the Linkerd await has now built into it. I'm sorry. I just had another thing kick off like right now, so I've got to disconnect.
Okay.
But yeah, it's essentially setting so that things start appropriately by default in Linkerd.
Yes, absolutely. So we won't take much of your time because you are right now in the phase of the multi-threading. But thank you very much, Jason. It's been a wonderful talking to you. Catch you again, and hope everybody who is watching this session learn a ton of cool stuff from the Jason. Bye-bye, Jason. Glad you joined us today.